Okay, I hope I am audible to all the students who are attending this lecture. We start with a very important and interesting topic today in mathematical methods in economics. This is called mappings. All students who are attending the lecture are requested to start writing this in their registers. We are doing mappings, also called as functions. So let's look at the review. So let's write the definition. Let f be a function which maps capital X to capital Y. Capital X is also a set, capital Y is also a set. That is, for each element, small x belonging to capital X, there exists an element f of x belonging to the set capital Y such that f of x is called the image. F of x is called the image of x with respect to f. So I again repeat the definition. Let f denote a function which maps the set x to the set y. That is, for each element small x belonging to the set capital X, there exists an element f of x belonging to capital Y such that f of x is called the image of x with respect to f. So if you want to look at the diagram, two sets, this is capital X, this is called capital Y. And f is a function which maps x to y. That means every element in x is mapped onto element in y. So guys, suppose we have x1, x2, dot 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 xn. Then corresponding to x1, what will be the image? F of x1. Corresponding to x2, what will be its image? F of x2. Corresponding to xn, the image will be f of xn. So as all students have done this in high school as well, we know that the domain of the function is the set capital X. The codomain of the function is the set capital Y. And what is the range? The range of the function is set of f of x such that small x belongs to capital X. The point to understand here is, what is the range? Range is the elements in Y which are receiving the arrows from X. I repeat, range consists of all those elements in Y which are receiving arrows from X. Another way of saying it, all elements in Y which have a pre-image in X. So guys, I can say that range is a subset of the codomain. Codomain consists of the whole Y. I repeat, codomain consists of the whole Y. But within that, the elements which are receiving arrows is called the range. So I hope all students have understood this. All values taken by the set X is called the domain. All values taken by Y is called the codomain. But within Y, the elements which are having a pre-image or the elements which are receiving the arrows is called the range. So I can say range is a subset of codomain. This means that range lies within the codomain. Range lies within the codomain. So I hope all students have understood till here, and I've also written this in their registers. So now I'm erasing all this off and moving forward. Okay. When is a function said to be well defined? So let's write the definition of a well defined function. Definition of a well defined function. So all students write this. A function f is said to be well defined. A function f is said to be well defined if and only if each element of x has a unique image in the codomain. Each element of x has a unique image in the codomain. That is, if x1 is equal to x2 in the domain, it implies f of x1 is equal to f of x2 in the codomain. So look at the words I am underlining. Each element, unique image. When is a function said to be well defined? First of all, every element of x should be related. And second thing, it should be related to exactly one element in y. For example, if I show you using an example, suppose this is x and this is y. And suppose there are three elements, x1, x2, x3. And corresponding to this, we have y1, y2, y3. So x1 is related to y1, x2 is related to y2. And now if I just leave it here, is it a function? Is this a function? No. Why? Because x3 is not related. Is this a function? Yes. You can see every element of x is related to exactly one element in y. What is y1? F of x1. What is y2? F of x2. What is y3? F of x3. So this is the example of a well-defined function. I can take another example. This was example 1. Let's take example 2. Set x, set y, x1, x2, x3, y1, y2, y3. Is it a function? Yes, it is a function. It is a well-defined function. Why? Because you can see every element of x is related and it is related to exactly one element. Even though you can see that y3 is not receiving any arrow, but you can see that image of x2 is y2 Image of x3 is also y2. That is fine. There is no harm in that. Every element of x is having a unique image. But guys, if I do it like this, example 3. Let's take this example. Let's take this example. So x1 is related to y1, x2 is related to y2 and y3, x3 is related to y4. Is this a function? No, not a well-defined function. Why? Because even though this is holding true, you can see every element of x is related, but x2 is not related to one element. x2 is related to two elements. That means this is not a well-defined function because x2 is having two images in y. So understand this, guys. X2 and x3 can have the same image, but x2 itself cannot have two images. That means the point to understand here is that this is possible. This is possible. But this is not possible. That means if this is the case, it is well defined. But if this is the case, it is not well defined. So I hope all students attending the lecture have understood the definition of a well-defined function. For a function to be well-defined, two things should happen. Every element of x should be related. That means arrows should be going from every element of x, and they should be going to exactly one element in y. That means every element in x should have exactly one image in y. Now, even if two x's are having the same image, that is fine. But one x should not have two images. Because if one x has two images, it is not a well-defined function. And then all students can write a note. Well-defined function. Well-defined function is also known as single-valued function. Well-defined function is also known as single-valued function. So I hope all students have understood this and have no doubts. Then let's move forward, and all students will now write the definition of a 1-1 function. So let's write the definition of 1-1 or injective function. 1-1 or injective function. So let's write the definition. A function f which maps x to y is said to be an injective or 1-1 function if and only if IFF means if and only if two distinct elements of x cannot have the same image. Cannot have the same image. That is, mathematically, if f of x1 is equal to f of x2, it implies that x1 is exactly equal to x2. That means if I take two different elements in the set X, they should not have the same image. They should have different images. Because if they are having the same image, it means they are exactly the same. You want to understand this using an example? Look at this. X, Y. This is a 1-1 function. This is a well-defined and 1-1 function. But if I take this case, suppose I take this case, this is not a 1-1 function. Why? Because two distinct elements of X have the same image, but X1 is not equal to X2. So I hope all students have understood the definition of 1-1 function, also called the injective function, and the example, which represents the diagram. So for a function to be 1-1, every element of X should have only a unique image. If two elements of X are having the same image, it is not a 1-1 function. Now, erasing all this, let's do the definition of onto function, onto or surjective function. So a well-defined function, f which maps x to y is said to be an onto or surjective function if and only if every element of the set capital Y has a pre-image. That is, for each Y belonging to capital Y, there exists and small x belonging to capital X such that f of x is equal to y. If I put it in simple words, when is a function said to be onto? In layman terms, a function is said to be onto if every element in the codomain is receiving arrows. Very simple. If every element in the codomain is receiving arrows from domain, function is onto. Another way of saying it, if f is onto, it means that your range is exactly equal to the codomain. Guys, if your range and codomain are exactly equal, that means the function is an onto function. We just said that range is a subset of the codomain. But when the two become exactly equal, then the function will be an onto or surjective function. You want to understand this using an example? Okay, so this is x, y. So this is an onto function. This is an onto function. But if I take another example, is this an onto function? This is not an onto function. Why? Because y3 belonging to the set y does not have a pre-image. Does not have a pre-image in the domain, that is set of x. You can see y3 is not receiving arrows from the set x. So this is not an onto function. Guys, in the second case, if I ask you in this case, what is my codomain? My codomain is set of y1, y2, and y3. But if I ask you, what is my range? The range is only y1 and y2, because only they are receiving arrows. So you can see range is less than codomain. But in this case, my range and codomain are exactly equal to y1 comma y2. So this is an onto function. So hoping all students are clear till here and there are no doubts. Okay, so let's do some practice questions now. So first of all, in case any student has doubt till now, you can unmute your mics and ask.
Excuse me, sir. Sir, in the example, second number wala, in this onto function itself, sir, is this a one function?
Yes,
Which is not
it is a one function. Yes. Why? Because every element of x is related and it is related to exactly one element in y. So this is a one function, but this is a one function. One function means every element of x should be related to exactly one element in y. That is happening. Even though y3 is left, that's completely fine. Every element of x is related and it's related to exactly one element in y. That means it is a one function. I hope students have understood this. Any other doubt, please ask. Okay, then let's move forward. So let's do some practice questions. So let x denote the set of all children. It's a Sater and Hammond question. And y denote the set of all human beings. And let f be a function which maps x to y, defined as f of x is the mother of x. The question asks us, is f well defined? Second, what is the range of f? And third thing, is f11? Is f onto? So guys, if I just picturize it, What does X denote? Set of all children. Y denotes set of all human beings. And F is a function which maps X to Y such that f of X is nothing but the mother of X. Now guys, is F a well-defined function or not? When is a function said to be well-defined? Every element of X should be related to exactly one element in the codomain. Now every child will have a mother. Every child has a biological mother, and every child will have only one mother. Biologically, it is not possible for one child to have two mothers. That means f of X is a well-defined function. F of X is a well-defined function. Why? Since every child will be having a mother, and every child will be having exactly one mother. Every child will be having exactly one mother. Point B. What is the range of F? That is something we all know. So range of F, who will be receiving the arrows? Only the mothers. Only the mothers in the set of all human beings will be receiving arrows from X. So range of F is the set of all the mothers of X. Range of F is the set of all mothers of X. Okay. Point C. Is F a 1-1 function? Guys, is it possible for two children to have the same mother? Very much possible. You can have two children having the same biological mother. So I can say that F is not 1-1. Since there exists a possibility of two children having exactly one mother. And guys, is F onto? When will F be onto? F will be onto if all the elements in Y are receiving arrows. But you will observe that only the mothers will receive arrows. If you have fathers in Y, that will not receive arrows. Fathers will not have a pre-image. Brothers and sisters will not have a pre-image. Uncle and aunts will not have a pre-image. Who will have the pre-image? Only the mothers. That means F is not onto. Since the range, which is the set of all mothers, is less than the codomain, which is the set of all human beings. Not all human beings are mothers. Some human beings are fathers also, uncles and aunts also, friends also. Okay, so I hope all the students have understood this example. Now there was no maths involved in this example, but it was all logic. So this was practice question 1. Let's do the second practice question. Let's involve some math. So let F be a function which maps natural numbers to natural numbers, and f of X is equal to X plus 1. Is F well defined? Is it 1-1? onto. So let's find that out. So guys, if you draw a diagram, what will you observe? Natural numbers, 1, 2, 3, 4, 5, and so on. 1, 2, 3, 4, 5, and so on. Now guys, 1 will be mapped onto 1 plus 1, 2. 2 will be mapped onto 3. 3 will be mapped onto 4. 4 will be mapped onto 5. 5 will be mapped onto 6, and so on. This will keep on going. So clearly we can see that f is a well-defined function. Why? Since every element in the domain is related to exactly one element in the codomain. If I ask you guys for this, what is my domain? Set of all natural numbers. What is my codomain? Set of all natural numbers. But guys, if I ask you what is my range? My range is 2 to infinity. My range is, I can say that my range is nothing but set of 2, 3, 4, 5, 6, and so on. Okay, so now let us, so it's a well-defined function. Is it 1, 1? Now, how do we check for 1, 1? So for 1, 1, we say that let the two values of x be x1 and x2, then f of x1 equal to f of x2 implies what will f of x1 be? X1 plus 1. F of x2 will be x2 plus 1, which implies x1 is equal to x2. This is how we show it's a 1, 1 function, right? If all students recall the definition of 1, 1 function, which you have written in your registers, how do we show that a function is 1, 1? F of x1 equal to f of x2 should imply x1 equal to x2. So therefore, this implies f is a 1, 1 function. But guys, if I ask you, is f onto? Is it onto? Clearly no. Why? Because you can clearly see that the range is less than the codomain. That is, there exists one belonging to the set of all natural numbers in the codomain which does not have a pre-image in the domain, which is the set of all natural numbers. You can see that 1 is not receiving any arrow. That means range is not equal to codomain. That means the function is not onto. So this function is well defined. It is a 1, 1 function, but it is not onto. So I hope all students have understood this. Let's do one more question. Let f be a function which maps real numbers to real numbers, and f of x is equal to x square. Now guys, let's check whether it's well defined. So again, is f well defined? One, one. onto. So if I draw a diagram, real numbers, I can take -1, -2, 0, 1, 2, and so on. Similarly, real numbers -1, -2, 0, 1, 2, 3, 4. So guys, -1 ka square is 1, -2 ka square is 4, 0 ka square is 0, 1 ka square is again 1, 2 ka square is again 4. And I can go forward, dots and all. So is F well defined? You can clearly see that F is well defined. See guys, for a function to be well defined, what should not happen? This should not happen. This should not happen. Because if this happens, then the function is not well defined. So you can see that F is well defined. Why? Since every element in the domain is related to exactly one element in the codomain. By the way, if I ask you what's the domain of this function, set of all real numbers. What's the codomain of this function? Set of all real numbers. So F is a well-defined function. Is it 1, 1? How do we check for 1, 1? Let the two values of x be x1 and x2. Then f of x1 equal to f of x2 implies x1 square is equal to x2 square, which implies either x1 is equal to x2 or x1 is equal to minus x2. You can see 2 ka square is also 4, minus 2 ka square is also 4. That means F is not a 1, 1 function. F is not a 1, 1 function. And guys, if I ask you to find the range, how will I find the range? We know that x square is greater than equal to 0. Square of any number is greater than equal to 0. What is x square? F of x. It's always greater than equal to 0. So guys, my range will be from closed 0 to infinity. I can also say that my range will be set of all positive real numbers. Now, if you check for onto, you can see that clearly range is less than the codomain. You can see -1, -2, 2, 3, they are not receiving any arrows. So you can write in the exam that they don't have a pre-image. So therefore, F is not onto. Since your range is positive real numbers, but your codomain is set of real numbers. So this is where I stop. I request all students to leave this meeting and join back using the same link. Please leave this meeting and join back using the same link. I hope all students have enjoyed this lecture.